Now it is the turn of Dr. Kaleem Sarwar, who will present application of CFD modeling for evaluation of spillways. So, Dr. Salim, it is over to you.
Thank you very much. The organizer of this seminar for giving me the chance to present the technical talk on the topic of application of computational flow dynamics to evaluate the hydraulic performance of spillways. So traditionally, we use the physical scale models. So, but there are some difficulties in physical scale models that includes the uh, that includes because the physical models are expensive and time consuming to construct and test, difficulties in representing the terrains and the concrete roughness, and the measuring devices themselves may interact with the flow and it disturb the flow behavior. And in terms of flow, we cannot visualize the streamlines and air entrainment cannot be examined reliably. So these are the issues with the traditional physical modeling. So that's why now the industry is thinking over the CFD modeling of the spillways. The CFD modeling has been started around the globe since 2000, and gradually it has been accepted by the hydraulic and the dam engineering community. For instance, if you type a keyword CFD in the database of ASC, you will find number of research papers representing the CFD modeling. So only in Australia, 16 spillway dams, spillways were upgraded using this CFD modeling technique. So this shows that the how it is rapidly being adopted by the dam and dam community and hydraulic engineering community. So CFD modeling, basically the governing equation of the CFD modeling comprises of the conservation of mass and momentum equations. So these equations give us the velocity, pressures, temperatures, and on the from these basic parameters, we calculate the other parameters like the viscous energies, cavitation index, and the distribution of the Reynolds number and the Froude numbers. So in order to capture the turbulence produced by the water, RNG model is associated with these governing equations for the capturing the turbulence in the model. So this is a set methodology for the CFD modeling that includes the pre-processing, validation, and the analysis, and the post-processing. So these steps include the whole methodology which we use during the CFD modeling. So one important step of the CFD modeling is the validation. So validation of the CFD model can be done by two processes, that is the proper validation process and then the pseudo validation process. So proper validation process is that process in which we use the prototype data to validate the model results. And the pseudo validation is that validation in which we use the physical model study data in order to validate our CFD model. So there are number of CFD codes are available in the market, like the Flow 3D, CFX, and the Fluent. So, however, industry industry is mostly using the Flow 3D for the CFD modeling. Why they use the CFD modeling? Because of some features that is the favor technique, which enables the to determine the voids or the flow region within the each cells, and the other feature is that it uses the structured or Cartesian mesh. Uh, with this structure or Cartesian mesh process, we can easily do the meshing. And the other one is the feature is the nested mesh. Through nested mesh, we can find out the more details at some area of interest. So, in order to accurately track the interface between the fluid and the air, it also uses the true volume of fluid method. So here is the table which gives the comparison between the available CFD codes in the market. If you see the mesh type for the flow 3D, it uses the structured mesh and multiple block mesh, while the Fluent uses the structured mesh and the Phonics uses also structured mesh. So if you see the user friendliness, so the backup from the academic users and the commercial users, that they say that it is excellent user friendly. So other, as compared to the other CFD codes available. So I will present here the two case studies. First case study is the CFD modeling of Mangala Dam spillway, which was conducted at the Civil CED department here in Lahore. So by using this model, we computed the cavity length, air attainment coefficients, cavity pressures, and the air concentration. So this model was operated for the four different wrap angles against the different operating conditions as shown in the table below. So these are the two reservoir levels against which the model was operated to compute the flow parameters as described earlier. So this is you can, in order to explain the shoot rater. At Mangala Spillway, shoot rater is provided. This is the shoot rater, and this is the sluice rater that is used to provide the air to the gate area, and this is the shoot rater which is used to provide the for the aeration of the flows for the chute. And it is on this rater, the water has installed the 10-degree ramp. If you see, actually, if you have visited the Mangala, you can see these are the four pipes of 3-foot dia, which are placed here in order to transform the air, in order to convey the air in the gated area. So here is the ramp is installed at this. This is the off-site type operator which is provided at the Mangala. So if you see another picture, you can see this is the jet length. As the jet length increases, that the air concentration increases within the flow. So this milky water shows that the sufficient air is carried by the flow. This is another view. You can see. So so if we when we compare the model results with the physical model data, you can see the discharge velocity of the incoming flow, water level upstream of the reactor, jet length, and the average cavity pressures. Then we find the difference within the 10% range. So it means our model was strongly correlated with the physical model data. So this is the model output for the air concentration profiles. This figure shows the air concentration profiles without the ramp at the conservation level. So another figure shows the air concentration profiles when 0.6 meter high ramp was installed. So if you see the results of the models, you can see that the air concentration at the at conservation level, this is the air concentration across the flow depth at this level. And this is the air concentration across the flow depth at highest reservoir level. So you can see near the bed, we have insufficient air, that is 2.5% only. And in this case, there is 3% only. So after installing the ramp on the rater, air concentration increased to 6% and 6.20%. It means literature says that it is recommended design practice that the air concentration near the bed should be more than 6% in order to avoid the cavitational damages. So another case study which I have included in my presentation is the case study of the Moment Dam, which is in process and we have get some results. So which is being conducted at the COWRE. So we through this model we calculated the depth average velocity and Froude number and the flow depth. to evaluate the hydraulic performance of the sealing basin, lower sealing basin. So for this case, model was operated at different reservoir levels and at full gate opening, and the results were, this is the 3D model of the moment and spillway of lower spillway, which was imported in the model, and the following results were, this is the model output for the depth hyper velocity. You can see the velocity is varying from the from 10 meter per second to the 57 meter per second. So, and this is another model output which shows the Frown number variation along the chute and the sealing basin. And this is the model output which shows the flow depth variation along the chute and the in the sealing basin. So when we compare the results of the model with the physical model data, that we compare the discharge of the two bays, that is the air, and the flow depth in the sealing basin with the physical model result data, and then the depth hyper velocity. So we find the percentage errors or difference between the physical models up less than the 5%. So it shows that the model is well validated. So up to now, different studies have been conducted at the civil engineering department and the at CEWRE. Here, this table shows the list of those studies which has been conducted. On the basis of these studies and my personal experience and the from literature, so here I have placed a few limitations and the suggestions for the future work.